Hey, what's up, Accelerated Algebra? So, sorry it was a short day today because of the PSAT. So, here is the lesson for Chapter 3, 3.1, talking about quadratic functions and models, day 1. So, I want you to download the notes first if you haven't already done so. Okay, let's talk about a quadratic function. A quadratic function is any function that's sort of in this form, ax squared plus bx plus c. We've seen this before. A is not allowed to be 0 in this case, because if it was, then we'd have a linear equation. So this is a general quadratic function, and when we graph these things, we get parabolas. Those are the shapes that we create when we graph quadratic functions. So I want to talk about the parts of the parabola. There are three main parts of the parabola that we need to be responsible for. One's the vertex, the axis of symmetry, and then the direction that it opens. And I have two parabolas over here on the right-hand side that we're going to talk about. So the vertex could either be the highest point, or it could be the lowest point. And so, for example, on this blue parabola I have here, the vertex would be literally right there. That is the vertex, and it is the lowest point because the parabola is sort of facing upwards. It can hold water, if you will, right? Whereas the red one, the vertex is right here. It is the highest point. That is the vertex. And sort of that happens because my parabola is facing downward, so it can't hold any water, so it has like a highest point. So think of these as bowls, right? Bowls on the counter, holds water or it doesn't hold water. So the vertex is either the highest or the lowest point. Once you understand the vertex, then we can start talking about the axis of symmetry. Sometimes I call that A period O period S for axis of symmetry. Well, the axis of symmetry is the line of reflection that every single parabola has. And the cool thing about it is it goes right through the vertex. It is the line that literally splits the parabola in half and makes it equal on both sides. So what I mean by that is, if there is a point on the parabola, say over here, that is a certain distance away from the axis of symmetry, then it is also guaranteed to be on the parabola in the opposite direction. That's what we mean by axis of symmetry. And lastly, we have direction. As you can see from here, they can either open up or they can open down. That's it. They're not going to open sideways or slanted in this particular class. They can, but just not in this class. So we either got up or we got down. So those are the parts of the parabola. All right, standard form for a quadratic. This is a very, very useful form. It looks like this. F of x is equal to a times x minus h squared plus k. Again, a is not allowed to be 0. Okay, so why is this important? Why do we care about the standard form for the quadratic? Well, one thing that we can do is we can read off a lot of important information. So, for example, the value out in front, the constant out in front, if your a is greater than 0, that implies that you're going to have an up-facing parabola. If your a is less than 0 or negative, that implies you're going to have a down-facing parabola. So up, it'll either hold water, or down, it will not hold water. So that's one thing it tells you right away. The second thing it tells us is exactly where the vertex is. The vertex is staring at you in the face. It's actually h, comma, k. H, comma, k is where our vertex is going to be. Please be careful that we're taking the opposite sign here. Right? K is left alone, but we take opposite sign inside the parentheses. Just like we go left and right when we did rigid transformations in the last unit. And the third thing that this beautiful standard form tells us is the axis of symmetry. Once we have the axis of symmetry, we can say the axis of symmetry is always going to be the line x equals h. So it reverts right back to it. So we get all these three important things, 1, 2, and 3, from this beautiful form. So we like this form. All right? So next thing would be, how do we graph a quadratic in standard form? So I have 4 steps. I broke it down for you in 4 steps that we're going to learn how to do in graphing a quadratic that's in standard form. So that means that it has to be in this form right here, because that's standard form. All right, the first thing we want to do is figure out is whether or not it opens up or down. Easy, no problem. Second thing, we want to get the vertex. Easy, no problem. So that's h, comma, k. We can do that. And with that, we want the axis of symmetry. Then we want to get the intercepts. Now, this might be something new, so I want to make sure I cover that for you. We're going to want both x and y intercepts, and lastly, we're going to plot some points. We're going to plot the points. So graph paper is very, very useful in this particular case. So we're going to first figure out if it opens up or down. Second, find the vertex and the axis of symmetry. Get both x and y intercepts if they exist, and then plot. That's our goal. So let's apply that structure to this problem here. I have a quadratic. It's in standard form. Remember, standard form is a times x. Oops, that should be x. X minus h quantity squared plus k. All right, so this is our standard form. Notice that it's in standard form already. So number one, does this graph probably open up or down? Well, this is going to open up, and the reason is because a is greater than 0, because a is a value of 2, and 2 is greater than 0. There it is right there. Number two, we want to figure out where the vertex is. Well, the vertex is at the point h comma k, remember. So that means that my vertex will be at -2 comma -1. And notice I took the opposite sign of the 2, but I left this one the same. All right, so I have -2, -1. And once I have that, I can then find the axis of symmetry, because I know it's related to the vertex, the x-coordinate of the vertex. So that means I'm going to have x is going to equal -2 for my axis of symmetry. Number three, what I want to do is I want to get the intercepts. Okay, so if I want both x-intercepts and I want y-intercepts. Now you may recall, whenever we try and find an x-intercept, we always set y equal to 0, because the x-intercept is going to be something comma 0. So we'll set y equal to 0. Well, what is y in this case? Y is just f of x. So I say 0 is equal to 2 times x plus 2 squared then minus 1. So I get 1 is equal to 2 times x plus 2 quantity squared. All right, now I can easily solve this for x here. I'm going to get 1/2 is equal to x plus 2 squared. So x is going to be plus or minus the square root of 1/2 minus 2. Now, when you plug this into the calculator, you get two answers. You get -1.2 and you get -2.7. So I encourage you right now to plug this in your calculator and get the two answers. Now, the two answers I'm talking about are the positive square root of 1/2 minus 2 and the negative square root of 1/2 minus 2. There's two of them there. All right, so to get the y-intercept, remember we always set x equal to 0. So if I set x equal to 0 in this case, what was my thing again? Oh, yeah. So I'm going to have a 2 times 0 plus 2 squared minus 1. What's just 2 times 2 squared minus 1? That's just 2 times 4 minus 1. That's just 8 minus 1. That's just 7. Good, so now I know the y-intercept is at 7. All right, I have all the information that I need. I'm going to take all this information and I'm going to plot it onto my x and y coordinate plane. So first of all, the vertex is located at the point -2, -1. So I'm going to go -2, -1. 1, 2, -1. Boom, here's my vertex. -2, -1. All right. I know that the parabola opens up, so now I also have an axis of symmetry right here. Here's the line x is equal to -2. I know my intercepts for x are -1.2 and -2.7. So here's -1. Here's about -1.2, right about there. And then here's about -2.7, right about over here. And I also know that the y-intercept is a positive 7. So on the y-axis, I count 1, 2, 3, 4, 5, 6, 7. So that means this point is on the graph of my parabola. Now, if this point is 2 units away on the graph to the right, then I know 2 units on the left is also on the parabola because of my axis of symmetry. Now I have all the information that I need to make a nice little sketch here of my parabola, and that's exactly what you'll be doing. Now, what happens then if we have to graph something like this? F of x equals 2x squared plus 8x plus 7. Well, this is no longer in standard form. This is in ax squared plus bx plus c form. And remember, we kind of like a times x minus h squared plus k. So we like this form, but we have this. So the question is, how do we go from this to this? Well, there's two ways that we can do it. All right. The first way I'm going to show you is the complete the square way right here. And the second way is going to be this sort of vertex -b over 2a, f of -b over 2a. You can choose whichever way you want. If we just want to find the vertex for here, so I'll just change this to find the vertex. Okay. If we just want to find the vertex of where this is, there's two ways to do it. So let me show you the complete the square way. It's going to look something like this. Let's go 2x squared plus 8x plus 7. All right, I want to complete the square on the x term and only on the x term. So that means I'm going to factor out an x, or factor out a 2. So I'll have 2. I'm left with x squared plus 4x, and then a plus 7. So far, so good. So then I want to have 2. Now I'm going to complete the square on the x term. So I'm going to have x squared plus 4x. And you may recall I have this magic number thing. Plus 7. Now, you got to be careful here, because if I'm adding something here, if I'm adding a magic number here, then I need to subtract that same amount on the end here. And the reason is because I'm working on one side of the equation, because all of this equals f of x. All of this equals f of x. All of this equals f of x. So I am not moving to the other side of the equation. So therefore, I need to add and subtract the same amount. Now the question is, what is the amount? Well, again, we're going to take half of 4, which is 2, and square it, so a 4 would go there. And you would think a 4 would go here too, but you have to be careful. You've already factored out a factor of 2. So really the number that goes there is 8, because that's 2 times 4. Now I am all set up to look at my answer. And I'm going to see that f of x is now equal to 2 times the quantity of x plus 2 squared, and then minus 1. Hey, there it is. My vertex is at -2, -1. You'll notice that this is the exact same problem as it was before, except I gave it to you in this form. So that checks out perfectly because, hey, check it out. Yep, there's the vertex. It's right there. All right, there's another way that you can do this. The other way that you can do this is you can take negative b over 2a and then substitute that value back in. So let me explain what I mean. If we are given f of x equals 2x squared plus 8x plus 7, and we don't want to complete the square, then here's what we can do. We could say, okay, the value of a is equal to 2, the value of b is equal to 8, and the value of c is equal to 7. Good. If I evaluate negative b over 2a, look what happens. I get negative 8 divided by 2 times 2. That's negative 8 divided by 4. That's negative 2. Holy cow. That's exactly what that says right there. No way. Okay, great. Well, then how do I get the negative 1 out of this? Well, I get the negative 1 out of it by taking the value of negative 2 and resubstituting it back into the original equation. So my function is essentially me evaluating f of negative 2. So that would be 2 times negative 2 squared plus 8 times negative 2 plus 7. This is 2 times 4 minus 16 plus 7. This is 8 minus 16 plus 7. Oh my gosh, that's negative 8 plus 7. Holy cow, that's negative 1, which is exactly what it says right there. Math works. Crazy. Okay, so if you're trying to find the vertex, you have two options. You can either complete the square, or you can do this negative b over 2a and then f of negative b over 2a. Either way is fine with me. Good luck, you guys. See you on Friday.